Okay, today we're going to be looking at how to transform or use transformations to graph absolute value functions. Yesterday we saw how to do this using a table, just graphing, picking x values, substituting them in, and getting the y values. Today we're going to learn about transformations. We all remember the now, transformations allow us to modify a well-known function, like a parent function, and move it around the coordinate plane. Okay, and it allows us to know exactly what our new function will look like as long as we know the well-known function and the transformations. Okay, now it doesn't necessarily need to be the parent function, it just needs to be a function that we already know. Okay, and then we can transform it however we want. So if we know what something looks like already, and we know the transformations, then we can create a new function, and that would be a transformed function. Now here are our different types of transformations. We have a horizontal shift, and that is represented by a number or value added directly to the x-coordinate. Okay, so when you look at the equation, the number will be added directly to the x-coordinate or subtracted. When the number is added to the x-coordinate, you shift left by that many units, and when the number is subtracted from the x-coordinate, you shift right by that many units. A vertical shift is where the value is added or subtracted directly onto the function. Okay, so it doesn't affect the x-coordinate per se, it affects the entire function. Typically, that's just added onto the end of the function. So like we have a normal function and we have a number added onto the end or subtracted onto the end. When the number is added onto the end, that shifts the function up. Okay, so it shifts it vertical shift up and down, horizontal shift left and right. So adding it directly onto the end of the function shifts it up or down. The other type is a reflection. Now, if you can create a reflection by making one of the coordinates negative, okay? So if you make the entire function negative, that will reflect it across the x-axis, okay? So that would be, we have our coordinate plane, that would be a reflection across the x-axis. And then if just the x-coordinate is made negative, that will reflect it across the y-axis. Okay, typically we are going to see this reflection across the x-axis. Okay, I don't think we're going to see any of these. All right, so making the function negative reflects it across the x-axis, making the x-coordinate negative reflects it across the y-axis. Now these are a little bit more difficult. The stretches, horizontal stretch, vertical stretch, horizontal stretch, these are a little bit more difficult. These happen when the function or the x-coordinate is multiplied by a number, and we're not going to see a lot of these. These are actually difficult to graph, so we're not going to see a lot of these, but you can think of these in the same way as you can slope. All right, they kind of affect the way that the slope works. So like if you have well, we might see these, but I don't think we will very much. Okay, so let's go ahead and take a look at how we can, well, first of all, this puts all of it together. It is kind of confusing to look at, but this is all of it put together, okay? So you have the y-coordinate equals, now if you got a negative sign outside the function, that's a reflection about the x-axis. This number, if you got a number being multiplied on the outside of the function, that's a horizontal stretch or a vertical compression. And then the function itself, if you got a negative sign inside the function, so affecting the x-coordinate inside the function, it reflects about the y-axis. And then the number multiplied inside the function is the horizontal compression or horizontal stretch. And then we have the x-coordinate. And then if you have a number being added or subtracted to the x-coordinate, and then a number added or will shift it left or right, and then a number added or subtracted onto the end of the function shifts it up or down. And this is just all of it put together. All right, so how do we use this information to change or modify or graph? Well, in this case, we'll be looking at absolute value functions, but you can use this for any type of function as long as you know what the starting function is. So in the case of absolute value, we start with the very basic parent function, y equals absolute value of x. And this is a well-known function because we know exactly what it looks like. It looks like this. Okay, we have our table, all the x coordinates and y coordinates. So -3 outputs 3, -2 outputs 2. Okay, all the ordered pairs are the same except for the y coordinate is always positive because of the absolute value. And we know that it creates this v like this, and we all know all the ordered pairs because they come from this table: 0, 0, 1, 1, 2, 2, 3, 3, -1, 1, -2, 2, -3, 3. Okay, so we know all of the coordinates. We know everything about this function. So we can know what any other function is just by identifying the transformations that affect it. Okay, so if we look at how we would graph, we just shift the points according to the transformation. So if we know the transformations, then we know how to move all of our points around. The final graph will be the new function. Just one thing to keep in mind, we always reflect before shifting vertically. Okay, we always do our reflection before shifting vertically. We are only going to see reflections about the x-axis. Okay, today we're only going to see reflections that turn it upside down. Okay, and we just want to make sure that we do that before shifting vertically. The horizontal doesn't matter because it flips it upside down, so the horizontal doesn't matter. We just want to make sure that reflection happens before shifting it up or down. Okay, so let's take a look at this first function. So we want to graph this function using transformations. We don't want to use a table today. Okay, we don't want to go through the work of using a table. So let's start with what the parent function looks like. I'm just going to put this on the graph, but I'm not going to. So we got 0, 0, 1, 1, 2, 2, 3, 3, and then we got these right here. Okay, I'm gonna make it a dotted line because this is not part of my graph. I'm just using this as a reference point. Okay, so this is the parent function. This is y equals square root of x. Now I need to know what type of transformation is occurring to get this function. Okay, so I need to look for what things are affecting it that make it unlike the parent function. And the one thing that I see here, there's only one thing, is I see a -4 being subtracted from the x-coordinate. Okay, that is the x-coordinate. I got -4 being subtracted from it. So if I reference back to what that type of transformation is, so a minus, that's a horizontal shift, so that's affecting the x-coordinate minus a number, so that's a shift right by that many units. So let me go back here. That must be a shift right by 4 units. All right, so my new function should be just like the parent function. The only thing is every point should be moved to the right by 4. Okay, so the vertex, 1, 2, 3, 4, should be moved to the right by 4. This point, 1, 2, 3, 4, should be moved to the right by 4. This point, 1, 2, 3, 4, should be moved to the right by 4. This point as well, and then this point, moved to the right by 4. Okay, every point should be moved to the right by 4. This will be my transformed function. So this graph that I'm drawing right here is the graph of, so if this pink one is the graph of y equals absolute value of x, which it is, then this blue graph is the transformation y equals absolute value of x minus 4. And you could check all of the ordered pairs and they would absolutely work in this equation, okay? So I no longer need this one because I'm just trying to graph my transformation function, and that would be this right here. So this is the graph of absolute value x minus 4. I didn't have to do a table because I could recognize the transformations. Okay, so I didn't have to do all of that work we did yesterday. I just needed to recognize the transformations. Now let's take a look at the next one, number 2. Now this one looks very similar, but it's not. It's not the same thing. Okay, the difference between this is that the minus 4, so we have y is equal to the absolute value of x minus 4. The minus 4 is no longer affecting only the x coordinate. Okay, before it was inside the absolute value affecting the x coordinate, but now it's no longer affecting the x coordinate. It's affecting the entire function. And if we go back to our table, when it affects the entire function and its subtraction, so we got minus 4 vertical shift minus shift down that many units. So this would be a shift down by 4 units instead. Okay, because if we compare this to the parent function, the only thing is this minus 4 affecting the entire function. So this is a shift down by 4 units. Okay, so I'll start with the parent function. I know what the parent function looks like. I know that it looks like this. And that means that I also know what the transformed function looks like. Okay, the transformed function is going to be shifted down by 4 units. Okay, so let me shift down. I'll shift the vertex down, 1, 2, 3, 4, right here. Shift this point down right here, 1, 2, 3, 4, right here. This one shifts down here. This one moves down here. I mean, I'm saying these points move down, but really every single point is moving down by 4, and I'm getting a new graph. It's still an absolute value function. However, it's been transformed. It's now been shifted down by 4. So if this pink one is the parent function, which it is, then this is the shifted function, absolute value of x minus 4. And it shifts it up or down. And of course, we don't need the pink one. All right, let's take a look at another transformation. Okay, so number 3, we have both of these transformations together. We have the minus 4 affecting the x coordinate, and we also have the minus 4 affecting the entire function. So that's going to be both of those shifts we just saw. Okay, not only is it a shift right by 4 because of this, it's also a shift down by 4 because of this. So let's go ahead and shift our parent function. So let me just put the points here so I know what points I'm shifting. Remember, this is the parent function. Okay, this is the function, the well-known function we're starting with. And I'm going to shift all of the points right 4 and down 4. 1, 2, 3, 4, 1, 2, 3, 4 right here. 1, 2, 3, 4, 1, 2, 3, 4 right here. Okay, so I know where all of these points are going to go. Right here. This one, 1, 2, 3, 4, 1, 2, 3, 4 right here. Okay, so I know where all these points are going to go. Let me just connect these now. And it looks like this. Got 2 transformations, both of them that we saw earlier. I'll erase the pink because I don't need that. And now hopefully you can see why this might be useful, more useful than doing just a table. Now remember, this doesn't only work with absolute value functions. This works with any type of function, as long as it can be compared to a parent function. Okay, so if you know, or a well-known function. So if you know a well-known function, you can very easily transform it. And then we got one last example here. And this one has a reflection in it. And this is the only type of reflection that you are going to see. All right, so only thing you got to remember here is that you do the reflection. Remember, let's go look at the page. You do the reflection before shifting vertically. Okay, so we'll do the reflection and then we will shift vertically. All right. Now, since the reflection is affecting the entire function, it's not inside here with the x, this will be a reflection across the x-axis. So that negative tells us reflect across x-axis. All that this is going to do is turn it upside down. Okay, and this is the only type of transformation we're going to be personally looking at, so that's the only one you got to be concerned with. You just got to turn it upside down. Now there's two other transformations here that we can see. We can see that there is a number being added or subtracted from the x coordinate. So we know that that's a shift right when you have a number subtracted, and the number subtracted is 2, so that's right 2. And then we have a number being added to the entire function. Okay, it doesn't affect the x coordinate, it affects the entire function. So that's up or down. This is up because it's positive, up by 4. So the order we're going to do this in is the order that we read it in. So this, and then this. All right, so the reflection first, then we're going to shift it right, then we're going to shift it up. All right, so let's take a look. Here's the parent function. All right, so I'm going to start with the vertex. Reflecting the vertex doesn't do anything. Okay, it just stays in the same spot because we're reflecting it across the x-axis, and it's on the x-axis, so that doesn't do anything. Remember, reflecting it just turns it upside down. So actually, let me just turn this upside down first. Okay, so I'm going to turn it upside down, so all of these like this. Okay, so that's what it would look like upside down. Now each of those points is going to get shifted right 2 and up 4. So 1, 2, 1, 2, 3, 4. So the vertex will go here. 1, 2, 1, 2, 3, 4. That point that I reflected now goes here. This one, right 2, 1, 2, 3, 4. This one's here. Right 2, 1, 2, 3, 4, and this one's here. Okay, now this point was reflected here, and now I need to move right 2 and up 4. 1, 2, 1, 2, 3, 4, right here. I mean, we can kind of see where it's supposed to go. Okay, so it looks kind of like this. So this green is my transformed function. Okay, you can notice how it compares to the parent. So this is the function right here. That's the function on the graph. This is negative square root, or sorry, negative absolute value x minus 2 plus 4. You can notice it's upside down, it's been shifted right, and it's been shifted up. The vertex, you can tell, is at 2, 4. And that's where it should be. Remember, h comma k, that's where the vertex is. Okay, so this is a lot easier than picking the correct x values and substituting them in and doing all of the calculations that are required for an xy table. This is a lot easier to just move it around because now we have the graph of the function that we want right here. All right, now these transformations, very important. We do see them for a lot of different types of problems, okay? Every function that you know that's well known can be shifted using transformations. All right,